Okay, so the last bit of the notes from Friday. So we're finding something called the derivative. What is the derivative? The derivative is the slope of the tangent line to a function or a curve. Okay, so slope, we know what that means, slope of a line. Tangent means it hits in one spot. It hits the function in only one spot. So like the red line, the blue line, the light green line, they only hit in one spot. Okay? So if they only hit in one spot, they're tangent at that one point. Okay? Okay, so let's see. So if it hits the curve at one point, if it's that means it's tangent, right? So it kind of ricochets off. To find that number, to find that slope, we use what's called the derivative. Okay, what's called the derivative. The derivative, the definition of the derivative is this guy in yellow. It's a limit, right? Tomorrow, I'm going to teach you other ways to find the limits, which are a lot shorter, right? To find limits here, or to find the derivative here, we could do it, right? But it took a lot of that work. I'm going to show you tomorrow a way to do that derivative of this guy, which will take a second. Okay? There's other ways to find the derivative, but I always start with a definition because the definition it will be tested on. You see it a lot on tests, but a lot of times we forget about it because it's like, oh, well, we learned the other ways. We learned the other the ways that we're going to teach you next week, or sorry, tomorrow, starting tomorrow. Okay, so we did a couple of them. So the last one we haven't done is number 3. Example number 3. Okay. Okay, so we have f of x. We have a function, 1 over x, right? We have our function, and these are the directions. Find the equation of the line tangent, equation of the line tangent at x equals 1. So right here, that means derivative. Okay, that means derivative. Slope of the tangent line, equation of the tangent line, anything like that means your first step is always going to be derivative. If you don't have the derivative, find it. Okay, so that's the first thing we got to do. So using the definition, definition, remember, said find the limit as x approaches 0 for f of x plus h minus the original over h. So remind me again, what does this mean to do? What does this mean? What did we do when we did this beginning part here? What would that mean? Yeah. Exactly. Put this anywhere we see an x. Okay. So let's go down to our function. We only see one x in the denominator, right? So instead of just x, it's going to be x plus h. Okay, so let's start writing it down. The limit as h approaches 0 1 over x plus h minus the original over h. Okay. Plug in 0, see what you get. Plug in 0, see what we get. Mentally, or you can actually do it on paper, it's up to you, but what do you get when you plug in 0? We got 0 over 0, right? We get 0 over 0 when I plug in 0 for h here and h here, because I get 1 over x minus 1 over x, which is just 0 over 0. So it means we have work left to do. Well, this problem should look very familiar because I think there was one on the test and last chapter, which we did. Instead of, it looked a lot like this, but instead of x plus h, it was like x plus 3. And then instead of h down here, it was like an x, right? So what we have to do is use some of our tricks from last chapter. We have to get these two guys together. In order to get these guys together, I have to subtract them. Subtraction involves common denominators. So that's what I'm going to do over here. So I'm going to take this guy, get it over here. So I have 1 over x plus h minus 1 over x. To subtract those, to combine those, I need a common denominator. So we start over here. What is this guy missing that this guy has? What is this guy missing that the other one has? An x, right? Some people say, oh, it's already got an x. No, it's got an x plus h. Those are different things. Okay, so it needs an x. So multiply the top. Now, what is this guy missing that the other guy has? X plus h. Okay. So what I have to do now is multiply these two guys. So I get 1x minus, and then I got to distribute the negative. So negative 1x minus h over xx plus h. Okay. I can combine, or I can cancel out the top. That when they combine, they're just opposites of each other, so they cancel out. And I'm left with negative h over x plus h. Okay. That I'm going to go put back. I'm going to go put this back where the other one came from. So let me rewrite it. I have the limit as h approaches 0 over h. Okay. So now plug it in. What do we get if we plug it in? We plug in 0 for h. What do we get? 0 over 0, right? We get a 0 up here. Oops. We get a 0 over here. I plug in 0 here. X plus 0 is 0, but these two guys combined are 0 or x squared. So I get 0 over x squared over 0. Well, if I have 0 on top, that's just 0. So it's really just 0 over 0. Okay. We got work left to do. So now what we did last chapter was we moved it. We changed this to a division problem. Negative h over x plus h divided by h. Well, when we're dividing fractions, we multiply by the reciprocal of the second one. So instead of multiplication or division, we get multiplication, and the reciprocal of h is 1 over h. Okay. These cancel out. So now I get negative 1 over x plus h. Oops. Okay, so let me bring that guy back now. So we get the limit as h approaches 0, and now I have negative 1 over x plus h. So now when I plug in 0 for h, what do I get? I get negative 1 on top. What do I get on the bottom? X squared. That is the derivative. That's f prime. That's f prime. That's the derivative. Okay? But that's not what they're asking for. They weren't asking for the derivative. They're asking for the equation of the tangent line. So we have to use the derivative. So I have to use the derivative. I ran out of space here, so let me move down a little bit further. Let's see. Okay. So, example 3. Okay, so here is what I have. That's the derivative. Now I have to find the tangent, or the equation of the tangent line. Well, we talked about this on Friday. Any of those, slope intercept, point slope form, standard form. Well, standard form we don't really start with. You always finish with standard form if you have standard form. Slope intercept and point slope, it doesn't matter which one you use. You rarely are they going to give you the slope intercept. Rarely do they give you slope intercept. So the place I would always start is point slope. That's the place I would always start, because it's easier to find. Okay. How do I find the slope? Let's start with the slope. How do I find the slope? How do I find, we did this on Friday. How do I find slope first? There you go. Yep. We know they said at x equals 1, right? They said they want us to find it at x equals 1. So that's the value we're going to plug in for x. X equals 1. So f of 1 equals -1, sorry, f prime of 1 equals 1 squared. That's -1 over 1, which equals -1. So the slope is -1. Okay. I know the x value. What's the number I just plugged in? +1, right? That's the x value. So the last thing I need is this guy right here. I need to find this guy right here. Once that, I'm done. So I got the x value. How do I find the y value? How do I find the y value? We did this on Friday, I believe. Yeah. Yep. X equals 1. Where is the y value? So what I'm asking is, what is the y value that goes with x equals 1? I know it's 1 comma what? That's what I'm asking. Well, to figure that out, you have to use the original equation, just like Srishti just said. So when I plug in 1 in here, I get 1 over 1. So what I did was I plugged in f of 1, which is 1 over 1, which is 1. Done. Okay. Oh, wait. One thing wrong. F prime of 1. See f prime of 1? I just noticed that right now. F prime of 1, I got -1, right? I only plugged in 1. When I plug in a -1, that's actually going to change it to a positive. So yeah, that was wrong. To get it into one of the other forms, you would have to distribute. If they want it in slope intercept form, you would distribute, then add 1 to both sides. If they want it in standard form, you would distribute, and then you would get this guy over here with y and add 1 to both sides. Okay, that's how you get it into slope or any of the other forms. Just depends on which form they want. Okay. All right. Okay, so what I'm going to let you guys do now